Hello class. Now we seem to be back for the third topic, and we saw each other when we were on the second topic, and that was number systems and the integers. Then today we are progressing on with the third topic, and I request that you pay maximum attention because I don't want to teach myself. Yeah, teaching myself would be boring, won't it? Yeah, it would be boring. Now, before we start on this topic, the third topic, which indeed is comprising of 3 subtopics, that is percentages and the fractions and decimals. Then I want first to check whether people are fresh by them answering this question before we start our lesson. Are you fresh? This is just a brain teaser, not so? Listen attentively. If a goat and a dog were in a race, a dog and a goat are in a race, and they want to pick the banana on the top of a mvule tree. Which one would pick the banana first from the top of the mvule tree? Just a brain teaser to check somebody's attention. Let me repeat. A dog and a goat are in a race. Then they have been sent to pick a banana on a tall mvule tree. Which animal would be the first to pick that banana on the top of the tree? Let us see. There's somebody who is fresh. I'll be chipping in some brain checkups. Yes, Grace wants you to try. Grace.
Okay, teacher, according to me, I say that none will be our first. Because both animals can't climb that tree. Okay,
I've seen people are very alert. That's very, very correct. Say that the answer again.
none of them.
None of them. That's very good. I loved that. Yeah, none of them. That's very, very correct. Okay, I'll be chipping in to check somebody's attention. Now, upon that, I can realize people are fresh. Let us start on the topic, and but we ought to clap for Grace. That's a very, very fantastic approach. Clap in order. You know the order of clapping, not so? Yeah, that's very good. Now, our topic is fractions, decimals, and the percentages. Remember, this is a long topic. Remember, I told you that the second topic was number systems and integers, and today we're on the third topic, and that is fractions and the decimals and percentages. How people they are not long time from their primary, therefore we shall be able to, I think, remind ourselves very, very clearly. Now I'm going to start with fractions. We exhaust them, then we go to decimals, but fractions will move concurrently with decimals. Fractions That means there are three basic subtopics. That's the fractions first, then decimals, each will be isolated, then percentages. And I request that you really participate. Then let us start with fractions here. And under fractions, we shall see the sub-themes, sub-headings. We shall see meaning of a fraction. Meaning of a fraction. Then, and examples. Yeah. Examples. Maybe examples will relate to me in real life. Are there some, do we really meet fractions in our daily life? I think Ruth will tell us, where do we really interact with fractions? Is it when we are sleeping? You never know. Then we shall see types of fractions, very many. Then converting improper fraction to mixed, and vice versa. To mixed and vice versa. Yeah, and vice versa. Then we shall also meet that part called the ordering fractions. Which fraction is bigger than the other? Ordering fractions. Then we shall meet now addition, subtraction. You see that, multiplication. And finally, division of fractions. That means we shall pick out each. Then word problems in real life for fractions. Word problems in real life. And most of this work, I hope people are going to work it out. It's just a reminder of Form 7 work, or P7, Primary 7. Then there, I will have finished up with fractions, and I will shift very fast to decimals. Yeah. Now we can start with I did remind you that to sit in this class, one, you must have a calculator, or else you should have a good brain that we shall do mental work. How people remember multiplication table, the table for 12. If you don't remember, some of you, I told you to go and watch these math tricks, how things are done easily. Like if we say to multiply a number, those who have math tricks in their head, you can have some rules. If you have programmed head, it can work. It can work. Like if we say somebody saying 22 times 9, we just say 22 times 10 minus 22. That means 22 times 9 is roughly that. That's around 180. 180 what? Because if you subtract here, that's 11, that's 198. If you have those programmed head, that to multiply by 2, you just add the same number twice. You see? 22 times 2, I will just say 22 plus 22, which is 44. 368 times 2, you can add it ordinary in the head. 323 times 2 is 646. It means if you don't want to use a calculator, you can program the head, not so. It would also work. 22 times 5, it would be easy. You just have to multiply by 10 and divide by 2. 22 times 5 is 22 times 10 divided by 2, giving you 100. That's how your calculators are programmed. Meaning, if you have a head having a calculator, then we shall leave you not to carry a calculator. You see that? If we say 23 times 4, it means you add 23 to 23 and the answer is added to itself. 23 times 4, you'd first get 46, and 46 plus 46 is 92. You see? Somebody will be wondering that now, that is how the calculator is programmed. That means you can multiply faster than a calculator. That's just a self-check. For people who might not have money to buy a calculator, you can program the head and it can work. The head can work. There is the head can be a calculator. So, yeah, the head can even get everything. You can, like if you say the square root of anything that you can program your brain and it will work like a calculator. I told you to watch YouTube. You type in math tricks and you'll be able to watch those things, and you'll be taught how to add in a simple way, multiply in a simple way without using a calculator. Yeah. Now let us start. That's meaning of a fraction, and Ruth promised us that what? She promised us that she's going to tell us what does the fraction mean, and do we really find it in food, or where do we interact with the fraction? Ruth, do you have anything to say about a fraction? If your singer asked you to explain to them what could be a fraction, what would you say? Or how do you demonstrate it so that somebody can understand?
I can say that a fraction, it can be used like when you're dividing something.
Okay.
Among many people.
Like
you have a mango and you have to divide it between two people.
A mango between two people?
Yes.
Okay.
Each one has to get a half.
A half. Each one will get a half. Oh. That means the fractions are even every day with us. Eh? That's very, very great. Thank you, Ruth. You are very, very good there. That means the fraction is now the definition could be what, Ruth? That each one gets a half after sharing a mango. Could you put it in simple terms? What could a fraction be? I'm seeing your neighbor wants to help you. Grace, wants to help us.
A fraction can be a division of a whole number.
It is a division of a whole number. Like
1, if you divide it, you can get a half, a quarter, a third, a fifth.
Okay. That's very good. Now we can summarize it this way. I think their arguments are accepted. That means Ruth said we can get a mango and cut it into 2 so that each takes a half. Then the other one will take a half. That means a half, this a half is part of the whole orange. That means a fraction is part of a whole. How to repeat that meaning? A fraction is a number which represents part of a whole. Now, I could ask, if somebody said read this fraction, how do you read it? What would you read that fraction to be? That one, this one here, how do we read? Yes? 2/5. Yeah, that's very correct. Or 2 out of? Out of this? 27th. That's accurate. That's correct. Now, okay, let us turn to types of fractions. Types of fraction. That's right. Types of fractions. Yeah, types of fractions. I hope you recall that knowledge from primary. Which fractions did we have? Yes, Grace?
Mixed fraction.
We had a mixed fraction. Then we had proper fraction. Then we had improper. Do we have another one? We had how many? 3. Okay. We start with the proper. What's a proper fraction? Yes.
Proper fractions is a fraction where the numerator is smaller than the denominator.
A fraction in which the numerator is smaller than the denominator. That's accurate. E.g., 2 out of 5. 2 is called the numerator, denominator. That means when the numerator, denominator. That means when the numerator is smaller than the denominator, we call it a proper fraction. Then what's improper? Yes, I can see Grace.
An improper fraction is a fraction where the numerator is greater than the denominator.
Yeah, exactly. That's very correct. Where the numerator, 5 out of 2. That's right. Then I would forcefully request Ruth to take her through what's a mixed fraction. Ruth, what's a mixed one?
A mixed fraction is where there is a whole number.
Where there is
A whole number
and then it cons e.g.
2,
2,
5 out of 8.
Out of 8. Why not 5 out of 2? Isn't it mixed also when we say 2 whole number, 5 out of 2, isn't it mixed? It's mixed. But it can be divided. That means it should be first divided before it can be left. It must be whole number and improper and a proper. A fraction containing a whole number and a proper fraction. If I taking notes of that. Now, let us turn to converting improper to mixed and vice versa. Yeah, that we are moving on. We are moving on. Other people can represent, if we say 2 out of 5 diagrammatically? How would it be diagrammatically before you go to converting? Yes, Grace, you are saying diagrammatically, how would it be?
You can use a table or a kind of a circle.
Circle, like a circle, how would you approach that?
And the total parts should be the number of the denominator. So the total parts will be 5 for that case.
Okay. I cut into 5. That means, are they 5? Then what do I do?
You have to shade the numerator.
To shade the numerator. That means I shade it 2. And that means I have 2 out of. Yeah. Let us see converting from what? From improper to proper, to mixed fraction. How do we arrive at that? Maybe I will give you time to discuss in your group. These numbers, you convert them and you give me the answer. You convert 8 out of 5. You see that? You convert for me that. Then you convert 81 out of 6 to mixed. Somebody would come and demonstrate how we arrive at that. How do we arrive at that? I hope you are discussing over. Yeah. Are we discussing over? Then I'll pick to one person to handle this and one person here. Fully finished discussing. Yeah, I can see you are through. Now, Grace, come and take over this. But you must be so clear in explaining, not so? Then I should have who? This one is called, this one will take up this. This from mixed. Be very, very clear.
We are converting from proper fraction from mixed fraction. So here we are going to need some division. It's going to be 8 out of 5, and you'll divide this by 5, 1. And by 5, 1 remainder. So the whole number will be the 1, and then the remainder will be the numerator. Then the denominator is 5. And then for this one, it will be 81 out of 6. By 6, 1, and by 6, 13 remainder 3. But then, okay, the answer will be 13 whole number, 3 out of 6. But then these 3 and these 6 can be cancelled. So, by 3 once, by 3, you will get 13 whole number, 1 out of 2.
Can you re-explain the part B again?
Okay.
Part B. It's not C, it's part B.
Part B, I say that we are going to divide. So it's going to be the numerator divided by the denominator divided by the numerator. So we shall get 6 divided by 6 to get 1. 18 divided by 6, we shall get 13, remainder 3. That's why I wrote this 13 whole number, 3 out of 6, as the answer I got after dividing these. But then remember, this 3 and this 6 can be divisible, so that's why I divided to get 1 out of 2.
Yeah. Yeah, that's good, that's good, that's good. Yeah. But you use the division, you wrote it as 13 whole number, 3 out of 6, but 3 could still divide through by, it had a common factor which was 2. I mean by 3, 1 by 3, 2. Yeah, let me have somebody convert from mixed to improper. Mixed to improper, you can come. Ruth, are you ready? Yeah. I think we write for you here. You must explain very, very clearly. Very, very clear. That's for number 1 out of 6, and part B, 3 on number 2 out of 3. Explain to your friends very, very clearly.
Now we've been given 4 whole number, 1 out of 6. So we shall have to multiply 4 times 6. And when we multiply 4 times 6, we shall add plus this 1. 4 times 6, which is 4 times 6 equals 24. 24. So we shall get 24 plus 1, which is equals to 25. So we shall say 25 out of 6. Because this is an improper, we've turned it into an improper fraction. Then here we shall do the same thing, we shall multiply and also add the numerator, which is 3 times 3, which is equals to 9. And 9 plus 2, which is equals to 11. So it is 11 out of 3, which is also an improper fraction.
Okay. Yeah. She has been a very, very good student. Have you loved her work? Yeah, I've too loved it. Yeah, now let us go to ordering fractions. Ordering. Yeah, that's a very good student. Keep on. How should we know this fraction is bigger than the other fraction? Okay, maybe we can start taking the example. Like if you divided the bread at home, if we say go and give a third to your sister and a half to yourself, who would have got more? Somebody saying their half is more. let us see. Okay. Arrange the fractions starting with the smallest. With the smallest, we can just have a half, 2 out of 5, see, 2/3, 2/3 there, and finally 1 out of 6. Which ones would be much? Which is big? And how do we arrive at that? Let me have suggestions. Let me have Patience taking over the explanation.
If you're using the diagrammatical method,
Yes.
obviously the smaller the denominator, the larger the object.
The smaller?
If you get like a mango and you say a half, it means you divide it twice.
Twice.
If you say 2/5, you have to divide it 5 times. It means the object will become smaller and therefore get smaller parts.
Now be specific. In comparison, 2 out of 5 and 2 out of 3, which would be big?
2 out of...
Are you saying that 2 out of 5 is big? Which concept are we ordering? Denominator, decision? Therefore, who would be big? 2 out of 5 or 2 out of 3?
2 out of 3.
2 out of 3. What if we had a third and 2 out of 3? Which would be big? A third would be big. The same denominators?
No, 2 out of 3 will be big.
I'm not understanding the logic of arranging, not so?
Because
Yes.
you get 2 thirds. Like, let me say this is a third and this is also a third. It will be big. But just 1/3 this one.
That means by just using by mind check, 2/3 is big. Okay. Somebody had an alternative. Let us see and see.
You can use the LCM method of the denominators. You find the LCM of the denominators, then you multiply the LCM times each fraction, and then you use the results to determine which one is small and which one is big.
That's the one you had. Okay. Let us examine the two methods, not so? Let me transfer the question up here. People have different views. Somebody has mental check, diagrammatic check. Let us see. Now, how do we order? Somebody gave us another method that we must use, LCM method. That method 1 is by using a common LCM in the denominator. Not so? Common LCM. Then method 2, by drawing and shading. Yeah. Is there a third one? Okay, let us, what's the LCM of 2? We can roughly check it here. The LCM of 2, 3, 5, and 6. Checking through 2, 1, 3, 5, 3, 2 again, 1, 3, and 3, 2 counting, 3, 1, 5, 1, 3, 5, 1, 1, 1, 1. What's the LCM? 30. LCM is 30. That's 2 times 3 times 5. That gives us 30. Now, she's told us that we multiply
A half times 30.
A half times 30.
Yes.
Is that very, very true? Or we multiply by a number that makes 30 in the denominator. There you are.
Teacher, let's try that we're multiplying 30.
We multiply by 30 up and down.
No, just up there.
Only here.
Yes.
That means we get, here we get 15.
Yes.
Okay.
Then 2/5 times 30.
By 30.
Yes. 6.
We get 12. 2/3 by 30. 20. A 6 by 30. We get 5. Which fraction is big? 2/3 is bigger. We check if our method is correct, not so? Ordinary division would give this one as well. We also know how to divide now decimals now. 1 divided by 2 by your calculator, what do you get? 1 divided by 2 gives you 0.5. 2 out of 5 gives 0.4. Then 2 out of 3 gives, that's 2/3 gives 6 recurring. Then 1 out of 6,
0.1 recurring.
1 recurring.
6 recurring.
1 6 recurring. Now, by observation, is the answer similar? Who is big here? Which decimal is big? Now you look at place, both have zeros here. You look at now the second place. You see that this has a 6, this has a 5. This one is it what is here? That means the method has worked. Common LCM method. Okay, that's correct. Then the shading method. What of the other? There are many methods, of course. Of course, you can try again by establishing the same one method, multiply by the LCM, check the biggest value, not so?
Yes.
That's okay? Then the other method is convert each to a decimal number. Then what is the other method again? Of making sure that both have 30 in the denominator. There you are. Like a half, 30 divided by 2 is 15. That means you multiply 15 up and what? Giving you 15 out of. Then you got the next one, 2 out of 5. 30 divided by 5.
6.
Times 6 times 6, giving you 12 out of. Then 2/3, 30 divided by 3 times 10 times 10 gives you 20 out of. Then a 6th, 30 divided by 6 times 5 times 5, that gives us 5 out of 30. Now you compare the numerators. Which one is big?
2/3.
Still the fact remains the same. Yeah, that means we can now let's look at our shading method. But that one. Method 1, multiply by a common LCM. Method 2, compare the decimal numbers. Method 3, establish the same denominator. Then compare numerators. Yeah, that's very great. That means how is our order now? Our order will be from the smallest, 6th, followed by 2/5, then a half, and finally 2/3. Yeah. Nata, do you get this correct? Now, you see, math has so many methods. As long as you don't gamble and arrive. See, as long as you don't gamble but arrive correctly. Yeah. Now, let us shift very fast to addition, subtraction, and multiplication. Yeah. How people are at ease. Now, you see, to enjoy math is to be flexible with many methods. And in math, ensure that the method you use is as short as possible. If your method is very long, you are going to error, because if you travel longer steps, you get tired. Yeah? And I'm requesting that being organized in math is very, very paramount. It means be organized and underline every answer. Let us start with addition and subtraction, and we shall also engage in the concept of body mass. You see that? Yeah, that means I can ask you that if you travel a half a kilometer followed by 2/3 a kilometer, how long do you travel? See, if you travel half a kilometer and then you add more 2/3, how far have you traveled? What would you use there? You'd add, or you'd, a kilo travels a half a kilometer, then proceeds to travel more 2/3 of the kilometer. You'd add. Yeah. Okay. Now, how do we carry out additions of fractions, especially if we say the denominators are the same, and in a case where you have different denominators, how do you handle that? So, I want to pick, I think people should discuss this. I want two people, you come and discuss clearly how you handle this and this. Yes? Yeah, I have here first. Called Ruth. Yeah.
Here, since the denominators are the same, we shall not do anything else, but we shall just go straight and add the numerators.
Say it again.
Since the denominators are the same, we shall go ahead and add the numerators.
Exactly.
One plus 5, which is equals to 6, out of 6. Now the numerator and the denominator are the same. We shall have to divide by 6, 1 by 6, 1. The answer will be 1.
Yeah, thank you. Yeah, come on. You are the ones discussing this, even subtraction. I'm waiting for patience. She's going to handle subtraction. 5 out of 6 minus 1. Yes, Grace, you handle part B.
Okay, since we have different types of fractions here, so we shall have to first...
Say that statement again. Since we have
different types of fractions, we shall have to change the mixed fraction to an improper fraction. So it will be the whole number times the denominator plus the numerator out of denominator. And we shall get 1 times 3 plus 2 out of 3 to give us 3 plus 2 out of 3.
Would that be in the side work?
Yeah, side work.
Yeah.
So since we have changed this to an improper fraction, we have got 5 out of 3 plus 1 out of 6. So since they are having different denominators, we shall use the LCM of the denominators. What's the LCM of 3 and 6? 6. So we shall multiply the LCM times each fraction. So it's going to be 5 out of 3 times 6 plus 1 out of 6 times 6. And these whole fractions have to be out of the LCM, which is 6. So 3 divided by 3, 1. 6 divided by 3, 2. By 6, 1 by 6, 1. Then 5 times 2 plus 1 times 1 out of 6. It will give us 10 plus 1 out of 6, giving us 11 out of 6.
Then proceed to convert it
to a mixed fraction by dividing. Okay. We divide 11 divided by 6. By 6, 1 by 6, 1 remainder, 5. So it will be one whole number, 5 out of 6.
Yeah, that's pretty good. Thank you. Very, very fantastic. Yeah, I'm very, very grateful. Yeah, how you have really interpreted that the LCM multiply each fraction but divide by the common, the same LCM. Yeah, that's very, very perfect. That's very, very perfect. Yeah, I hope I will do. Now, assuming a student used this approach, of course I've told you that there are several approaches. A student can just use cross multiply. 1 times 6 plus 6 times 5 out of 6 times 6, which gives us, that is 6 plus 30 out of 36, which is 36 out of 36, which is 1. That means the failure, if you can't get LCM, especially in such a case where you can fail to get the LCM, you can as well play it via that way if you didn't want to bother yourself with the LCM. But now there will be a task of cancelling through. That means you would simply cross it, multiply 6 times 5 plus 3 times 1 out of 3 times 6, giving us 30 plus 3 out of 18. Now there you are, 33 out of 18. And now even the calculator can give you a mixed fraction. Did you know that? Yeah, it can do it. That means now dividing 33 by 18, how do you get? 1.8, you write 1 is the whole number. One remainder, you can multiply back, and this will give us 18. This gives us, it gives 15. It gives 15. That means you have one whole number 15 out of 18, but still there is a common 3. 3 gives us 5 by 3, 6, yielding you 5 out of 6, the same answer. That means you can use cross multiplication. Let us have patience doing up with that. That's very great. There are many methods of handling math, but you choose the shortest and simplest. Yeah. Patience. Be very, very clear.
According to this one, this number has the same and this one is a whole number. This one here. So we have first change it into an improper fraction. 1 times 3 is 3 plus 2 is 5. That is 8 out of 3, right? 8, sorry, it's 3. This is 7 out of 3. So 5 out of 6 minus 7 out of 3. The LCM of these two is 3. So 5 out of 6 times 3 by 6.
So say that again, the LCM of who and who
6 and 3
is, try to find it roughly, is 6.
Yeah. Sorry for that mistake.
That means you must check it if you are not sure. Not so?
Yeah.
Yeah.
By 3, 1 by 3, it's 2. 7 times 2 is 14. So 5 minus 14 gives a negative.
Have you isolated the terms? You have isolated because I don't see how 5 out of 6 is mixed in there. Can you be demonstrative? Your friends must be listening very, very well.
Okay, so
you can try to explain it deeper, how you arrive.
we are looking for the LCM of 6
and 3, which is
by 2, 3, by 3, 3, by 3, 1, by 3, 1. So,
which is 6.
times 3 is 6. 5 out of 6 times 6. 5 times 1 will give you 5. 7 out of 3 times 6. By 3?
You mean the method is wrong?
Yes.
It's very long, the one you are using. do you want a suggestion from a friend?
Yes, good.
Grace suggests, Grace, come and suggest very, very fast. She has said that method is mechanically long. Ruth, you want help? Come and help. You are afraid of a negative.
Alright, here is a mixed fraction, so we shall have to change the mixed fraction into an improper fraction. I shall written here 1 times 3, which is 3, and 3 plus 2 out of 3, which is 5 out of 3. Now we shall come back to this 5 out of 6 minus 5 out of 3. So now we shall cross multiply, which is equals to 5 times 3 5 times 3 minus 5 times 6 out of 6 times 3, which is equals to 15 minus 30 out of 18. So we shall have to get negative 15 out of 18 by 3. Here is 5 by 3, 6, which is equals to negative 5 out of 6.
Yeah, I think we have only applied one method. Thank you, Ruth. Patience tried to use very long methods.
Just made one mistake.
You made one mistake. Oh, sorry. What was that mistake?
Instead of multiplying there on the whole number,
Yes,
I instead of adding my multiply.
you multiplied.
Yeah.
That was very bad. Yeah, but mistakes are what? Are human or common? Because a mistake can't be a human being, not so. Yeah, thank you. That is very great. Let us go to multiplication and yeah, multiplication. How do you multiply fractions? Our time is not on our best side. Work out h. How do you multiply a fraction? Time was 5 out of 6. Yeah, I want to have suggestion there. Yeah. I'll mix in a real number 20 kilograms of dough of fifth. You can demonstratively tell us here. Pensions, are you willing to come and demonstrate the math? Yes, number 2. Oh, okay. Let us have Grace. Then Patience will take on number 2. But you must be so clear because I don't want to repeat your method.
Okay, in this method of multiplying, we are going to multiply both the numerators and both the denominators.
So say that again.
In this method of multiplication, we are going to multiply both the numerators and then both the denominators. So it will be 2 times 5 out of 3 times 6 to get 10 out of 18. We can divide by 2. We get 5 by 2, we get 9. So So we shall have 5 out of 9. We can leave it in an improper fraction since we are not given any mixed fraction information.
That's great, Grace. Thank you. Pensions come on for 20. Yeah, we are impressed with Grace's work. It's very, 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 very fantastic.
20 kgs. Oh. So this all represents multiplication. So it will be 20, but we make this one a fraction out of 1 times 1 out of 5. And 20 is divisible by 5, so we do by 5, 1 by 5. 4 times 1 gives you 4. 1 times 1 gives you 1.
Okay, thank you. I think that's pretty good, not so?
Yes.
Yeah. Now, let us go to division very fast here. This time she has been very good. Very good. Okay, division, work out this. Yeah, in the class, people know their math. Know their math. Yeah. If you have 2 out of 3 divided by 1 out of 18. See that? Yeah. That means I'm expecting correct solution. Then I'm also expecting somebody is very much willing to take over. 1 whole number 2 out of 7 divided by, you now divide by a 3 out of 8. Out of 8. Then I'll have the last student taking that. If you divide the 200 meters by divide the 200 meters by a half. Yeah, you are 3. Therefore, I expect you choose one. Come and start on. The order will be the order.
Alright, I'm doing number 1. We have 2 out of 3 divided by 1 out of 18. So we shall have to find the reciprocal this side. And when we get the reciprocal, this division sign changes into multiplication.
Say it again.
This side we shall find the reciprocal. And when we get the reciprocal, this division sign will change into multiplication. 2 out of 3 times 18 out of 1. And this 3 can be divided by 18. By 3, 1, by 3, 6. So 2 times 6 out of 1 times 1, which is equals to 12 out of 1, and that gives us 12.
That's right. That's very wonderful. Yeah. Taking off. Now, what if a student just said that 2 out of 3 divided by 1 out of 18, you just cross multiply? Mental, now that's mental work. This times this divided by this, 2 times this divided by 3. You see that would be
36.
Divided by now 3 times 1. That would be 36 divided by 3. 36 out of 3 is 12. Yeah. pretty direct, mentally speaking. Yeah. Okay, let us have. Come and take over this number. Yes, Grace. Then Patience will take up the last one. And you see, this thing is a bit wide. You save time. You only take 1 minute.
Okay. Since we are in division and still we're given two different types of fractions, we shall first of all change this mixed fraction to an improper fraction. 1 times 7 plus 2 out of 7. 1 times 7 plus 2 out of 7. So it will be 9 out of 7 divided by 3 out of 8. You can either get reciprocal or you can use the method of cross multiplication. So it will be 9 times 9 out of 7 times 8 out of 3. And this can go by this 1, by this 3. So we shall have 3 times 8 out of 7 times 1. 3 times 8, 24. And this can be divided by 7, 1, by 7, 4. It can be divided, okay.
We can change it into a mixed fraction.
Yeah. 24 out of 7. By 7 once, by 7, 3 remainder. 3. Okay. 3 whole number, 3 out of 7.
Yeah, that's very great. Yeah, Princess. You can rub off since they are under understood.
So by means divide. So it's 200 meters divided by a half. So you can turn this into a fraction. 200 meters out of 1 divided by a half. 200 meters out of 1. So it is times 2 out of 1. So it's 200 meters times 2. You get 400 meters.
Yeah. Thank you very much. Yeah, thank you very much. Now, we can't add to that, but I will bring in this concept of body mass. Give you a number to try out with the body mass rules in action. In action, I don't know how many will aid us before I go to add problems. Then we bring in decimals very. Yeah, now I'm giving you a concept application of body mass. Hope you are ready. So now, body mass. What does that? What body mass stand for? The brackets of division, multiplication, addition and subtraction. That means you start with what? You start with handling the brackets. That means you start with handling and followed by division of division, then multiplication, subtraction is the last. Yeah. Let me put here a number. We see somebody come into play here. Work out 3 out of 5 of 3½ divided by 2/3. That's one student. Then another student, 5 whole number 1 out of 9 plus 3 whole number 1/3. Then divide by 3 out of 2 times 6 whole number 4 out of 15. Can somebody come and interpret body mass very, very well? Yes, you can rush here. Handle part A. Part A. 3 out of 5 of. Yes. Whoever is ready, come.
Okay, as a law of body mass states that we have to work out brackets then of the division. So here we don't have brackets, so we have only of and division. So we have to work out the of first. Of can change to multiplication, but you have to first turn this into an imperfection.
Yeah, you can do stand the hand point and the
3 times 2, 6 plus 1, 7 half. Divided by 2 out of 100. So we work out this first. So 3 out of 3 times 7 out of 5 times. Okay, 3 times 7, 5 times 2, divided by 2 out of 3. So it's 21 out of 10 times 3 out of 4. So we have to just arrange now.
Are you following what she's saying?
Divide by 2.
Those who don't have mental math, the calculator can convert for you. Now, get that calculator. There is a fraction button on the calculator written on A over B. After division, you press that button, it will immediately, with that question, are you through?
I think.
You think you are through? You think you are through? I think. Okay. You first handled the of. Yeah. That was very correct. And then you handled it well, then you reached here. That is,
Three whole number, 3 out of 2.
have you seen how the calculator converts? It will say 3, it will indicate such, but it will be indicating 3 whole number, 3 out of 20. Have you seen that? Yeah, now I want to have this candidate, I mean this is student here, come take over that, then we drop to, we leave out fractions alone. Let me first put it for you here. Out of 15. Yeah, you come and be very clear and very elaborate. Patience, are you okay? Mm-hmm. Yeah.
Okay. Since God's rule says that we should start with the brackets, so we shall start with these brackets. And these brackets have mixed fractions, so we shall first change them to improper fractions. 5 times 9, 45, plus 1, 46 out of 9, plus 3
I want mental math.
9 plus 1, 10 out of. But remember, these two fractions are in brackets. Divide by 3 out of 2 times. We shall also change this one to an improper fraction. 6 times 15. Patience. Yeah. 6 times 15.
Mentally, I want it done mentally.
90 plus 4. 94 out of 15. So we shall first work out those that are in brackets, and we shall first get the LCM of 9 and 3, since this is addition. The LCM of 9 and 3 is 9, so it will be 46 out of 9 times 9 plus 10 out of 3 times 9 out of 9. But remember, all of these are in brackets. So it will be divided by 3 out of 2 times 94 out of 15. So by 9, by 3, so it will give us 46 times 1 plus 10 times 3 out of 9. Divided by 3 out of 2 times 9, 4 out of 15. So 46 times 1, it will give us 46 then plus 30 out of 9. So what is 76 out of 9 divided by 3 out of 2 times 84 times 4 out of 15. So the next we have finished the brackets and we have no of, but we have division. So we shall apply the brackets at the division sign. So it will be 76 out of 9. We shall get the reciprocal 3 out of 2. Change this to multiplication. That will give us 2 out of 3 times 94 out of 15. So, can we divide n here?
Without a calculator.
9 plus 6, it will give us 13. We can't divide it, and here we can't divide it by 2. Then
You can multiply it at once with the calculator. It can help you.
We can
It's very big.
multiply it 76 times 2 out of 9 times 3 times 94 out of 15. What do we get after multiplying 76 times 2?
76 times 2. We get 152.
Divide by?
No. Remember, we've only divided 72 times 2. I mean 76 times 2. So we also have 94.
No, let us first talk about this one.
Why not the whole of it? Just the
Can
whole
work out the whole of
multiplication.
it since it's all multiplication. Six times 2 times 94.
14,288.
Out of 9 times 3 times 15.
405.
So if you divide, what you get? 14,288 divided by 405.
Which divisor are you using to divide? The head.
35.27.
Have it in fraction format.
Whole number 113 out of 405.
Yeah. That is for such big things. You can use a calculator. Yeah, thank you very much, Grace. You've been very, very clear. And we love that, those methods. Yeah. Now let us proceed to word problems here. I'll give you some numbers at the end of the discussion. You'll try them. And then before you go to decimals, let us go to how can we apply fractions in real life. How can we apply fractions in real life? Okay. That means we shall just call it word problems in fractions. And here it's what you deal with. But I'll just give two numbers for the interest of time. And you'll try them. Word problems in fractions. Question 1. I want to see people interpret. Yeah. Dennis went to Nakawa market with the 64,000 shillings. 64. This is basically Uganda shillings. You need to be specific. Uganda shillings, 64,000. He spent a quarter on buying shirts. and 4 out of 5 of the remainder on shoes. The remainder on shoes is how much money did Dennis spend altogether? How much money did Dennis spend altogether? I think we shall do one, then others I'll give you in the revision. Who can interpret that number for us and we see? You want to try, Ruth? Yes, Ruth, come on. Yeah, Ruth is very, very willing.
Question is saying Dennis went to Nakao market with 64,000 Uganda shillings. He spent a quarter on buying shirts and 4/5 of the remainder. And what is this remainder? He spent a quarter on buying shirts and 4/5 of the remainder on this, on shoes. How much did Dennis spend altogether? So what we shall first find is the remainder. And how we shall find the remainder? We shall say 4 out of 4, which is like 1 whole of this, minus a quarter, which is equals to 4 minus 1 out of 4. It is equals to 3 out of 4. This is the remainder and 4/5 of the remainder on shoes. So we have to find the fraction that he spent on shoes. They said 4/5 of the remainder, and the remainder is 3 out of 4. 4 out of 5 of, which is the same as times 3 out of 4. So we shall multiply 3 4 times 3 out of 5 times 4, which is equals to 12 out of 20. It can be divided, it can be reduced by 2, 10, by 2, 6, and still it can be reduced by 2, by 2, 5, by 2, 3, which is equals to 3 out of 5. This is the fraction he spent on, this is the fraction he used on shoes. So how much did Dennis spend altogether? Remember he went with 64,000 Uganda shillings. So we shall first find the amount of money he spent on buying shirts, since we have the fraction, and also we shall first add the fractions. The fraction that he used.
So say the two methods again. How shall we arrive? We shall. You said we can find the independent money, or we can add the fractions.
Yes.
Say it in your words. It's me who has said.
We can find the amount of money he spent on buying shirts, and also we can find them differently. The one he spent on buying shirts and the one he spent on buying shoes. And we can also add the fractions first, and then we find the money all together. So we shall add the fractions.
Okay, take us through. We are learning.
The fraction he spent on buying shirts, which is a quarter, plus the fraction he used it on buying shoes, which is 350. So we shall cross multiply, which is 1 times 5 plus 3 times 4 out of 4 times 5. So 1 times 5, which is 5 plus 3 times 4, which is 12 out of 20, which is equals to 17 out of 20. Now here it can't be reduced. So
Finish up. No, you can just add someone step down. Okay, let us see.
So we shall let
You want to continue from there?
Yes.
Okay. Thank you, Grace. Thank you, Ruth. Yes, really. Yeah.
Okay, I think you all understood all the steps that she took till where she found the sum of the fractions of both the fraction that Dennis spent on buying shirts and that he spent on buying shoes. So the total fraction is this. But then the total is 64,000 shillings. And if he spent this fraction, then what shall it be? That the sum of all this is 64. It will be 20. So meaning 20 is representing the 64,000 shillings, the total sum of money. So if 20 parts, we can put them in parts, represent 64,000 shillings. What of one part? What if it was 1 out of 20? So that's why I'm saying what of one part. So it will be 64,000 shillings divided by 20. Then what of the 17 parts, the total fraction of these two, the shirts and the shoes? So 17 parts will represent 64,000 shillings out of 20 times 17. A 0 and a 0. By 2, 1. By 2, 32. So 17 parts will represent 3,200 shillings times 17. And that will give us
50,400.
So this is the amount that Dennis spent on both the shirts and the shoes.
That's very great work. Thanks, great, very great. But why do you think you didn't just directly multiply? Because this is a total fraction, this is a total money.
Yes, ma'am.
Not so?
Yes.
Could that work? This time was that? Is it the same as this? Okay. Yeah. The other methods, as he explained, but we can't exhaust that. Now, fractions have ended here, and remember the whole topic is still going on. We are now going to decimals, but we shall handle their fractions. I'll give you numbers when we are starting on decimals. I think I give you numbers, just a few. Then we close fractions, and have you seen, you have understood this handle? Let me give you the first question. Work out the following. Yeah. You can visit our new curriculum book for senior 1. You do all those exercises, and also you can visit other math books of senior 1, like one from School Certificate Mathematics Book 1. School Certificate Mathematics Book 1 to mix in with the new curriculum written by Ballon, but you look for School Certificate Mathematics Book 1. Now let me give you some numbers here, even some word problems like 2 only, and you'll go and look for more yourselves. You can even go on internet, you watch so many. Since you have those devices, not so. Work out the following. A is 2/3 minus I'm just giving you the ones that will keep you busy for a short time, but you'll visit very many for yourself. This is 7, 2 out of 7, then yeah, you'll try them out. I'm only giving you two here. Then 2 word problem is number 1, work out. Then number 2. When you visit that book, School Certificate Math, you'll do so many, it has very many numbers. Let me read for you the word problems, 2 of them. It says here that Kayongo took 3/4 or 3 out of 4. Kayongo took 3 out of 4 of a loaf of bread. Wamala took 3/5 of the remaining loaf. Wamala took 3/5 of the remaining loaf of bread. Find what fraction was taken. Find what fraction of the loaf of bread. Find what fraction of the loaf of bread was taken by the 2 boys. Now the last one, Namlondo spent a 5th or 1 out of 5. Namlondo spent a 5th of her money on sugar. comma of Herman on sugar, 3 out of 8 on pens, 3 out of 5 on pens, and 1 out of 15 on pencils, 3 out of 8 on pens, and 1 out of 15 on pens. She has a 15th on pens. She has shillings 3,000 left in her pocket. She has 3,000 left in her pocket. How much did she have before she bought the items? How much did she have before she bought the items? Now let us close fractions from there. Then we shall be discussing decimals. And that means decimals is to be started. Yeah.